and it's between alpha and beta. Okay. See, sucrose itself is dextrorotatory, but after hydrolysis, it gives dextrorotatory glucose and levorotatory fructose, which we know levorotation fructose is more than glucose, and the mixture becomes levorotatory. So the product is named as invert sugar because initially it was dextro and now it's levo because of the high levorotation of fructose. So I was saying that C1 of one glucose and C4 of another glucose of alpha alpha glucose, and we have H plus of we have hydrolysis, right? When we hydrolyze it, it'll form a hemiacetal linkage, which is this, and then it's gonna form this, and that can be reacted with your tolerance reagent and all that shit. So the order becomes what? Initially it was alpha beta, and then alpha alpha, then beta beta. Correct. Sorry guys, I kind of misinformed you guys over here. So we need a hemiacetal linkage, and our hemiacetal linkage is present over here. It's present over here. Hemiacetal is OHOR, and that is present over here. So make sure you read the question properly. It says fuck. It says C1 of second glucose in solution. Here it says C1 of glucose in unit. So this unit, this part. So I'll be telling some tricks to draw these structures effectively. So first one is glucose, right? You have alpha glucose. Alpha means it's on the same side, meaning on the right side, right? We right is the good side, like that. So it has double, like double of everything is good, right? So it has double. Alpha has double. Just remember that. So if this is OH, this will be opposite. This will, you have one double, and then everything else just comes opposite. Sorry guys, my mistake. This is to CH2OH. So we have four OH groups and one CH2OH group, like that. Now trick for beta is that beta is very negative, right? Beta, who cares about beta? Like, it's trash. So we have to create all of the alternating ones. So we start with the same. Sorry, we start with the opposite. Okay, OH, H. Then we keep alternating. OH, H, OH, H, and then down comes the, sorry, then we have another one, which is, what do you say? Your OH, H, and then CH2, OH. Am I doing this at 1, 2, 3, 4? Yeah. So it is opposite like of this without the double. So this one you switch, then you keep alternating until you get CH2OH. So beta D galactose is also like that. So we go OH upwards, same as your beta, and then you just draw like this, like opposite, but one of them has to be same. So OH, H, which is this one, and then down you have an OH, and then H, sorry, CH2OH. Let me just check. Oh shit, that's wrong. What the fuck? Okay, fine. So CH2OH is also on the same side. This is very weird to remember. So basically, glucose, opposite, no, first two same, then opposite, alpha. This is alpha. Beta glucose is first one inverted, then alternate, then galactose is first one inverted, and then alternate on one alternate, then one double, then three, a triple, because this is kind of a triple. So the main takeaway from here is starch, main storage polysaccharide of plants. It's polymers of alpha glucose and contains of two components, amylose and amylopectin. Amylose is amylose is water soluble component which consists about 15 to 20% of starch. and it's containing of 200 to 1000 alpha D plus glucose units held together by C1 C4, C1 C4 linkage, C1 C4 linkage. 85%, the remaining is contained by amylopectin. Amylopectin is insoluble in water. Insoluble in water. C1 C4 is the glycosidic linkage of like alpha C1 C4 is the glycosidic linkage, and C1 C6 is the branching linkage. Amylose, okay, we remember the amylose is water soluble and amylopectin is water insoluble. Here is the branching chain. C1 C6 is for branching. We have cellulose now. Cellulose is really hidden. They can ask this a lot. Cellulose is straight chain polysaccharide, straight chain, and it's composed of beta D glucose units. Only beta D glucose, and it's joined by glycosidic linkage between C1 of one glucose and C4 of the second glucose. C1 C4 linkage.